Hello everyone, this is Siddharthan. This is the fifth project video in our machine learning course series. So in this video, we are going to see how we can build a machine learning system that can predict whether a news is fake or real. Okay, so this is a very interesting project because in this case, we are going to use textual data. Okay, so as this is textual data, there is a lot we can do here. And in the previous project videos, we have dealt with only numerical data. Okay, so let's get started. First of all, let's understand the workflow we are going to follow. First is the collection of data. So we need to collect this news data. Okay. So this data set we are going to use is basically a labeled data set. So it consists of several thousand of news articles, and it will be labeled as either it is real news or fake news. Okay. So it again contains other details such as the author of that particular news, the title of that news, etc. Okay. So once we have this data set, we need to pre-process this data. Okay, so there is a lot of work that need to be done in this pre-processing step when compared to the numerical data, because computers and systems doesn't understand text, they doesn't understand characters, they just understand numbers. So we need to find some suitable way to convert this text present in the news to meaningful numbers that the machine can understand. Okay, so we will perform various functions in this data pre-processing steps, so it will be very interesting, I promise you. Okay, so once we pre-process the data, once we convert this text into meaningful numbers, we need to split the data set into training and test data. So this is the same thing we do in most of our machine learning projects. So because we train our machine learning model with the training data set, and once we train our machine learning model, so we need to evaluate our model. Okay, so that will be done using the test data. Okay, so we feed this training data which is pre-processed to our logistic regression model. So in this project we are going to use a logistic regression model because this is a binary classification project. Okay, so binary classification means we are going to classify the result into two types. It's either real or fake. So when it comes to this kind of binary classification problem, logistic regression is always the best. Okay, and a lot of people have requested me to explain the working and the math behind the models in my videos. So in this video, what I'll do is, once we are going to implement this model in our Python code, I will give you a detailed explanation on the math behind the logistic regression model and how it works. Okay, so let's look into it later in this video. Okay, so now let's come back to this workflow. Okay, so once we train this logistic regression model, we get a trained model. So we will do some evaluations on this model. So we find the accuracy score of this model using the test data. Okay, so once that done, we have a trained logistic regression model. So in this trained regression model, so we feed new data to this model. Okay, so for those which we don't know whether the news is real or fake, so once we give the data to our model, it can predict whether the news is real or fake. So this is the workflow we are going to see. Okay, so let's get started with the coding part. Okay, so I will be doing the coding in the Google Collaboratory. So if you are new to Google Colab, you can watch the video 2.1 in my channel. Okay, so the name of that video is Google Colab Basics. So in that video, I have explained you how you need to access Google Collaboratory. Okay, so I'll give a card in this video so that you can watch it. Okay, now first of all, let's understand about this dataset. I have already uploaded this dataset. So the size of this dataset is about, as you can see here, it's around 95 MB. So it will take some time to upload here. So you just need to give this upload option and you need to upload this dataset. So I'll give the link to this dataset file, this CSV file, in the description of this video. Okay. Now let's understand what are the features in this dataset. So it contains ID of the news. Okay, so there will be around 20,000 news articles, and this is the ID or serial number of that news. Okay, so this is not that much important for us. And then we have the title of this news article. Okay, so it basically contains the title. So what is about that news article? Then we have the author name of the news article, and then we have the text. So this will be a long paragraph about the news. Okay, so there will be the text of this data set. Okay, and then we have labels. So as you can see here, a label that marks whether the news article is real or fake. Okay, so there will be two labels. 1 and 0. So 1 represents fake news and 0 represents real news. Okay, so you can find more about this dataset in Kaggle. So I have downloaded this dataset from Kaggle. Okay, so now let's start the coding thing. First of all, we need to import the dependencies. The dependencies are nothing but the labels and the functions we need in this code. Okay, so I'll make a text here, importing the dependencies. So to run a cell, you can press shift plus enter. So it runs that particular cell and goes to the next cell. Okay, now let's import the libraries that are required for us. First, let me import numpy as np. Okay, now I'll import pandas as pd. Okay, now we need to import another library called as regular expression. So import re. So re stands for regular expression. So it is very useful for searching the text in a document. Okay, so import re. Now import nltk dot corpus. So we need to do, so from nltk dot corpus import stopwords. So I'll explain about all these terms, stopwords and other functions when we are using it. Okay, now let me import it directly. So corpus generally means the body of that particular text, the important content of the text. Okay, so NLTK stands for Natural Language Toolkit. So natural language is, the text we are going to deal. Okay, so that generally means natural language. So and then we need from NLTK dot stem dot ported import ported stemmer. Okay, so what is this basically is, so we will perform a function called as stemming. So this stemming takes a word and removes the prefix and suffix of that word and returns the root word of it. So this is the general description about stemming. So I will explain you detailedly what is meant by stemming once we will do that process. Okay, so in this video. Okay, so now we need to import from sklearn dot feature extraction dot text import TF-IDF vectorizer. So this function TF-IDF vectorizer, so this is what we are going to use to convert the text into feature vectors. So feature vectors are nothing but numbers. Okay, so this is the function we will be needing. Now we have to import from sklearn dot model selection import train test split. So this function is used to split our dataset into training data and textual data. Sorry, test data. Okay. Now let's import our model from sklearn dot linear model import logistic regression. Okay. Now let's import the accuracy score from sklearn dot metrics import import accuracy score. Okay, so I'll run this. So press shift plus enter. Okay, so first we have imported numpy. So numpy is very useful for making numpy arrays, and pandas is useful for creating the data frames and storing the data in the data frame. So and then we have this regular expression library. So it is useful for searching words in a text or paragraph. Okay, and then we have this natural language toolkit dot corpus. So from that we have included stop words. So stop words basically means those words which doesn't add much value to a paragraph or text. Okay, so these can be the words such as the, a, and so it can be the articles or it can be the words like where, what, when, and those kinds of words. Okay, so those words are stop words. So we need to remove these kind of stop words from our dataset because it doesn't add much value about the context of the data. Okay, so that's why we need to import this stop word. So using this function, so we will remove all the stop words in our datasets, and then using this module in the library natural language toolkit nltk.stem.potter. So we have used imported the function potter stemmer. So this function is used to stem our words. So it basically gives us the root word for a particular word. Okay, so we will discuss about that in more detail during that stemming procedure, which we will do later in this video. Okay, and then from this feature extraction dot text in the sklearn library, we have imported TF-IDF vectorizer, which is used to convert this text into feature vectors. Okay, and then from model selection, we have imported this train test split function, which is used to split our data set into training data, test data. Okay, and then we have imported our logistic regression model from sklearn.linear model, and then finally we have imported accuracy score from sklearn.metrics. Okay, so now we have need to import, we have need to download this stopwatch from nltk library. So put import nltk and nltk dot download stopwatch. Okay, so I'll run this. This will download all the stopwords present in it. So as you can see here, now let me show you what are these stopwords. Okay, so I'll print those words. Print stopwords dot words. So we need to remove the stopwords from English, right? So mention the language which you are going to use. So in this we are going to use English, obviously. So English. So these are the stopwords I have told you. As you can see in this words here, so these words doesn't add much value to our dataset. So during the stemming procedure, we will also remove all these words from our dataset. Okay, so these are nothing but the stopwords. So I'll just make a comment here. Printing the stopwords in English. Okay, so now let's continue our code. Okay, so once we have imported all the dependencies, we have downloaded this stopwords module. So I have printed and showed you what are the important stopwords that we are going to remove. Okay, now this is data collection and data pre-processing part. So I'll make a text here, data pre-processing. Okay, so as you can see here, I have already uploaded my data set. So it is named as train.csv. Okay, so I'll copy this path. Okay, now we need to load this dataset into a pandas data frame. Okay, so loading the dataset to our pandas data frame. So pandas data frame loads the dataset into a more structured table, so that's why we use it. So I'll create the variable as new dataset, sorry, news dataset. Okay, so we have this news dataset. So you, as you can see here, the dataset is a CSV file. So CSV means comma separated value file. So we need to use the function PD. So PD represent pandas. Okay, so PD dot read CSV. So this will read the CSV file. So we need to mention the path of that file. So I'll copy the path of this file. So copy path. Okay, so this will load our train.csv dataset to this variable called as new dataset. Okay, so I'll run this. Okay, so this will load the dataset. Now what we will do is, let's check the number of rows and columns in the dataset. So news dataset dot shape. So as you can see here, we have 20,800 news articles and 5 columns. So this basically means the first element in this list means the number of rows. So we have 20,800 rows and five columns. So this 20,800 means the number of news articles. So we have totally around 20,000 news article and 5 features. So let's try to print the first 5 columns of this data frame. So print the first 5 columns, sorry, first 5 rows of the data frame. Okay, so you can do that by using the function yet. So mention the data frame name, which is news dataset. So news dataset dot yet. So I'll run this. So as you can see here, this is the ID which we have seen here. So these are the features we have. So first we have the ID column, which gives the serial number of the news, and then we have the title of every news, and then we have the author of that news, and we have the text in this dataset. So this is the detailed explanation of this news, and we have label. So the labels will be either 1 or 0. So 1 represents fake news and 0 represents real news. Okay, so this is the sample of our dataset. So totally we have 20,800 news. Of that I have printed the first 5 news in our data frame. Okay, so these are the 5 columns. So one is the ID, title, author, text and label. Okay, now what we will do is we need to check whether some values are missing in this data set. So let's count it, counting the number of missing values in the data set. Okay, so you can use that. So sorry, you can do that by using the function is null. So mention your data frame name, which is news dataset dot is null. Okay, and dot sum. So this will count the number of missing values in each column. Okay, so as you can see here, there are no missing values in the ID, this serial number column, and there are about 558 missing values in this title column. Okay, so out of these 20,000 news, about 558 news are missing their title values, and 2,000 news are missing their author name, and 39 are missing their text, and we have all the labels, so it's 0. Okay, so there are no missing values in this label and ID. Okay, so let's understand why these things are missing. So basically it means while we are preparing the dataset, we might not get the title of a news or author of a particular news or the text of a particular news. So that's the reason. So for some news we may have only the title and author, so in that cases the text will be absent. Okay, so similarly we have the title and text for some news, but the author name is missing while we are preparing the dataset. So that's the reason. So in this case, we have a very large data set because it has almost 20,000 data points or 20,000 news articles. So these missing values are not that much important. So we can drop this missing values or we can replace it with null string. Okay, but if a lot of the values are missing, so we will use some methods like imputation. So in that imputation method, we will do some processing to replace those missing values with appropriate values. Okay, so we will look into it in some other project. So in this case we don't need to do that because we have enough data set to train our machine learning model. Okay, so if we have a very small data set, in that case we cannot drop the values because we already have a very small data set, and in that if we drop some values we cannot make good predictions. Okay, but in this case, as we have a large data set, we can replace the missing values with null strings. Null strings are nothing but empty string. Okay, let's do that. Replacing the null values with empty string. Okay, so I'll mention the data frame name, which is news dataset. So news dataset is equal to, so I'm creating the new variable which is the same as our data frame name. So news dataset dot fill na. So this will fill the missing values. Okay, so this fill na fills the missing value with whatever we need to fill. So here I'll mention a null string. So null string can be mentioned by just putting 2 quotes. Okay, so this is a null string. So I'll run this. This will replace the missing value with null string. Okay, now So this is one of the important step in our project. So for our prediction, we are going to include title and author. So what we basically do is we will combine this title and author together, and this is the data we are going to use for prediction. We are not going to use the text because these texts are so large. So it can be a huge paragraph and it takes a lot of time for processing. So I am going to use this title and the author column together for our processing. Okay, so if you want, you can use this text data. Okay, so instead of using the title and author to predict whether a news is real or fake, but using this title and author yields a very good accuracy score, a very good performance. So hence I'm using it. So if you want, you can also try this text data. Okay, so now what I'm going to do is I'm going to combine this title column and author column together. Okay, now merging the author name and news title. Okay, so these are the two main important features required for us. So in our news data set data frame, I'll create a new column named as content. Okay, so I'm going to create a new column named as content, and I'm going to store this combined value of title and author in that column. Okay, so let's mention it here. So I want a new column named as content, and that I want the author column and the news column, sorry, the title column. So I want to separate them with a space, so that's why I'm using this space inside this quotes plus so basically this plus symbol concatenates two strings. Okay, so I want to combine this author column with my title column, and I want to store that in a new column called as content. Okay, so I'll run this. Now let's print our data set and see. So print news dataset columns. So let's print this content, that is the new column, and see. As you can see here, first we have the author name because we have mentioned the author name first and the title next. So you can see here the author is Daryl Lucas. So this author name and this title will be combined and stored in a column called as content. Okay, so this is this content column. So we are going to use this particular data to make the prediction. So we will be using this content data and labels to make predictions. Okay, so now we need to separate this particular data. Sorry. So this particular data, which is the content column and labels separately. So let's do that. Okay, separating the data and label. So in this case, the data is the content column and the label is nothing but the label column. So I'll create the variable as x. So x is equal to news dataset. Okay, so news dataset dot drop label. Okay, axis is equal to 1. So you can just mention label, or you can mention columns is equal to label. So basically what I'm doing here is I want to remove this label out of this data frame. Okay, so I don't want to give this label together with the data. So in this data frame, I will remove this label and store all this data in one variable, and I'll store this label alone in one variable. So this drop function basically removes the label column from our data frame. Okay, so you need to mention the column name here, and you need to mention the axis is equal to 1 if you are removing a column. So if you are removing a row from a data frame, you need to mention as axis is equal to 0. As in this case we are removing a column, I am mentioning the axis is equal to 1. Okay, now I am creating another variable called as y, in which I will store all the label. Okay, so news dataset label. So this will load all the label value to my new variable called as y. So I'll run this. So you can print this x and y. So I'll print x and then I'll print y. So as you can see here from our original data frame, all of these values except the label will be stored in x, and other values, the labels will be stored in Y. So you are not seeing this other columns such as title, author, because so it will be not shown. So because of that reason, it is showing that sorry, these three dots. So it basically means there are several columns between it. So these columns are nothing but our title column, author column, text column. So our last column is content. So that's why it's just printing the content column alone, because there won't be enough space to print the entire thing. So that's why it's not printing those things. But the author column, title column, everything is stored in this variable X. And in Y, we just have these label values. Okay, so as you can see here, we have totally 28,800 rows and 5 columns in X. Okay, now what we need to do is the stemming procedure. So I'll create a text called as stemming. Okay, stemming. So what is stemming? So I'll just make a description here. So stemming is the process of reducing a word to its root word. Okay, so this is the stemming procedure. So as I have told earlier, so it will remove all the prefix and suffixes because they don't give much meaning to our text. Okay, so for example, let's say that we have several words, like, so I'll just take an example here. So there can be several words such as actor, actress, acting, and what else you can say. So several such things, right? So for all these words, the root word is act, right? So for all these words, the prefix and suffixes will be removed and the main root word will be captured. Okay, so that is what we are going to do that in the case of stemming. So this is a very important step because we need to reduce the words as much as possible to have a better performance on our model. Okay, so once we do this procedure of reducing the words to its accurate root word, we will perform the function of vectorizing. Okay, so in that vectorizing step, we will convert these words to their respective feature vectors. So feature vectors are basically the numerical data. So once we convert this text data to a numerical data, we can feed it to our machine learning model. Okay, so here you just need to understand that stemming is the process of reducing a word to its root word. Okay, so I have given an example for you here. So let's see how we can do that. So in the previous cell, we have imported the function called as Porter stemmer, right? So this is the function we are going to use for this purpose. So there is a lot of things we need to do here. First, let me make a variable called as Porter stem. Okay, so let's say Porter stem is equal to, so you need to mention this function which is Porter stemmer. So I'll mention this here. So Porter stem is equal to Porter stemmer. So this Porter stemmer function will be loaded to this variable, and now I'll create a function. So for creating a function, you need to mention this keyword diff. Okay, so which means basically define. So what happens here is, like, in some cases you need to replicate a particular code snippet. So we cannot do the same code again and again. And again, for simplifying several lines of code to a simple word, we use this function. Okay, so create a function. So I'm creating a function called as stemming. So in that you need to mention some input value. Let's say it's content. Okay, so define stemming and content. So we will, by this procedure, we will create a function and the name of that function is stemming. Okay, and in that bracket we need to give some input value. Okay, so I'll just create this function and explain you what are the things are. So first I'll create this all the procedures and explain you. So let's say stemmed content is equal to re.sub. So don't worry, I'll explain you what are these things. So you need to mention a string, and okay, Okay, so I need put arrow at here. So I'll search for character, so you will get this character map in your windows. So I need this upward arrow yet. Okay, so I'll select it and copy. Okay, so if you are not sure what is the shortcut for this particular symbol, you can do this same step that I'm doing. So if you know the shortcut, you can do it. So I don't know sure what is the shortcut is, so I'm doing this procedure. So in your Windows 10 system, just search for character, so it will open that character map. So if you scroll down, you will find this particular symbol, so you can copy this symbol from here. So we need to mention it here. So A to Z and A to Z. So I'll explain you in a moment what is meant by all these terms. Okay, so just wait a minute. Okay, so and then stem content is equal to stem content dot lower. So stem content dot split, and then stem content is equal to port stem. So this is the port stemmer function we have loaded here. So port stem dot stem for word. Okay, so word. So I'll create a for loop here. So for word in stemmed content, if not word in stop words dot words English. Okay, so now we need to join these words. So again, stemmed content is equal to join. Okay, and finally we need to return stem content. Okay, so this is the function we are going to use for stemming our text data. So this may seem very complicated to you at the moment, but it's actually very simple. I'll explain you all about this function. Okay, so first of all, we are creating a function named as stemming. Okay, so this is not an inbuilt Python function. So we are creating it using the keyword diff. So diff means define. So we are creating a function called as stemming. So this word particularly called as content represents the input we are going to give it. So if we give a particular text inside this stemming function, it will do all the processing that we have mentioned here. Okay, so I want to name this input as content. Okay, so it's not that we have need to mention the same word we have did in this case. So we have created a column called as content, right? So it's not that we need to mention the same word. So now let's see what is meant by all these words. So once you give a input value, a input text, all these processes will be carried out. So in the first step, what we are doing is we are calling this regular expression library. So as you can see here, we have imported this regular expression library. So it is useful for searching a paragraph or text. Okay, so I'm using this function called as sub. So sub basically means, so as you can see here, it substitutes certain values. Okay, so in this I have mentioned this upper arrow at right. Okay, so this upper arrow it means exclusion. So this is a particular set. Okay, so from this A to Z, so I am mentioning a set which contains small a to small a to small z. Okay, and then we have capital A to capital Z. Sorry, this should not be. Okay, so we have lowercase a to lowercase z and lower uppercase a to uppercase z. So I need to get all these sets, sorry, all these alphabets. So what I'm basically trying to do here, so here is, so in our data set, as you can see here, there can be numbers, right? So there can be numbers, there can be commas, and there can be quotes, a lot of things. So we don't want all of those things, we just want all the alphabets and words. Okay, so that's why I'm doing it. So we are taking this set, so small a, that is lowercase a to lowercase z and uppercase a to uppercase z. So this is our set, and we are excluding everything that is not present in this set. So this particular line basically removes everything that is not alphabets, that is not a to z. Okay, so this removes all the numbers, punctuations, etc. So if it is not present in this set, which is alphabets, it will remove it. So all the numbers and punctuations will be removed. So I want all this to be replaced by this content, okay, which is basically the text. So I want to feed this content column. So this content column basically represents the author and title column combined, right? So I want to feed this data to this stemming. So this will basically remove all the numbers and other things, as I mentioned earlier. So that is the purpose of this step. So I want to remove all those things from my content except for alphabets and words. Okay, so now what I am doing is, so and I have mentioned space here. So what basically it means, right? If there is numbers or commas or quotes, those will be replaced by a space. So that's why I mentioned a space here. So I want to do this processing in my content, which is basically the combined form of the author name and text name. Okay, so once we have done that, we need to convert all the alphabets to lowercase letters. So those words some words can be in uppercase letters, so I want to convert all those to lowercase letters, because it can create some problems in processing. The machine learning model or other processing may think that uppercase letters means some significant things, so we don't want that. So I'm converting all the words, all the letters to lowercase letters, so it is very helpful. So once we done that, we are splitting it to respective list. So all these words and text will be you know uh, converted to list. So it will be splitted and it will be converted to a list. Okay, and then what we are doing is we are stemming these words. So we are taking each word, okay, and we are doing this stemming function. So this stemming, which means taking a word and reducing it to its root word. So we need to do it in all the words. Okay, but in this case we are removing the stop words. So I have mentioned you earlier what are stop words. So we have printed these stop words, right? So these are insignificant words, so we don't want these kind of words in our data set. So we need to remove. So basically what I'm doing is I'm just using a for loop to parse in my data frame and remove all the words, stop words, and choose only the words that are not the stop words. So as you can see here, so for word in stemmed content, so in my content I want to take the word if it not in this stop words library. So okay, so I am taking all those words that are not stop words, and I am performing the function pot stem, so which means pot stemmer. Okay, so once I have done that, I am joining all the words. So that is why I'm using this join function. Okay, so this is the function of this stemming function. Okay, so and finally we will return our processed text, which is stemmed content. Okay, so first we need to remove all those except the alphabets. So we will remove numbers, punctuations, commas, quotes, etc. Okay, so and once we have done that, we will convert all of them into lowercase letters, and after that we will split our dataset into list, and then we will perform the stemming function on all those words except the stop words. So this will remove all the stop words. So this particular for loop will remove all the stop words, and only the significant words will be returned to this pot stem function, and those words will be reduced to its keyword. So that's what we are doing here. So once we have done that, we will join all the words in this stemmed content. Okay, so this is this function. So let me run this. Okay, now we have created this function. Now we need to apply this function to our content column, right? So let's do that. So use dataset content is equal to use dataset content dot apply stemming. Okay, so basically what I'm doing here is I'm taking the content column, which is the joint form of the author name and title name of the news article, and I am applying this stemming function. So this will do all the processing in this stemming function, and it will return that to a new column called as content. This the same column in this data frame. Okay, so that is what we are doing here. So let me run this, and this will take some time, so it will take a minute or two because the processing has to be done for a lot of words. So okay, so let's wait for that. And another important thing here, so if you practice this code, there is a good chance this will throw an error. Okay, because you need to pay close attention to this symbol here. So in some systems this unicode symbol is not cannot be replicated. So if you face some error in your code, what you should do is download the collab file from the description. So I'll give the link for this collab file. Just copy this exact code and you can run that, and you can definitely get your answer. Okay, so once you are making the code, just make sure that this symbol is the same. Okay, now we have applied the stemming procedure. So now let's print this stemmed content. Okay, so use dataset content. Okay, so I'll print and show you. Now as you can see here, we don't have any uppercase letters, so you can see this content before processing. So we have capital letters, so in almost all the words, and then we have a lot of punctuations, quotes, etc. So all those will be removed. Okay, and the words will be converted to their respective root words. So you can see here there are no lowercase letters, so all the words will be the root words, and all the stop words which are insignificant will be removed from this data set. Okay, so that is the reason for doing this stemming procedure. Okay, so I'm telling you again, if you face some issues, just copy this entire function and just try it again. Okay, so now what we will do is let's create again the x and y thing. So we just need this content value for our processing. So I'm not using this text column. Okay, so because if we use this, there will be a lot of processing, because each of this text will be a huge paragraph and it will take a long time for processing. But if we do the training with this title and author alone, it will yield a very good result, and it is very easy for us. So I'll just separate this columns. So separating the data and label. Okay, so I'll create x is equal to news dataset. So I want the content value to be in this dataset. So x is equal to news dataset content dot values, and I want the labels to be in y. Okay, so news dataset dot values. So I'll run this. So we don't have to make this particular cell, so we don't have to just make this x and y cell. So I made this because I wanted to show you that the data set can be splitted by this. So original data we need is only this content. Okay, so I am just getting this content column and the label column. So I'll print x. So this will be our data and y will be our what should I say, the labels. Okay, so we have a lot of values, and that's why it's shown as 3 dots. Okay, so we have these many values in it. Previously we have all the columns such as IDs, title, author, etc. So it will be hidden in this particular place. And now in this X we have only this content column. Okay, so I want only this content column. I'm storing this content column to X. Now let's print Y. So print Y. So this will show the label. Okay, so 1 means fake news and 0 means uh, real news. So you can check the shape of Y. So shape of Y is nothing but 20,800. So in this particular variable Y we have 20,800 values. So all those values cannot be shown here. So that's why it has shown this in a short form by 3 dots. Okay, so we can again. Okay, so this is the thing we are going to feed our machine learning model. So we have this content column in X and label column in Y. Okay, now this value is still in textual form, right? So I have told you earlier that computers cannot understand text. So we need to convert all these text into meaningful numbers that the computer can understand. So as I have already told you, for that purpose, so we will be using this vectorizer function. So TF-IDF vectorizer. Okay, so now let's use it. So this is converting textual data to numerical data. Okay, so I'll create a variable called as vectorizer, and I'll store the vectorizer function, which is TF-IDF vectorizer. Okay, so now you can fit the value of vectorizer dot fit x, and now let's get that x is equal to vectorizer dot transform x. Okay, so let's understand what this vectorizer function do. So we are using a special vectorizer called as TF-IDF vectorizer. So TF stands for term frequency and IDF stands for inverse document frequency. Okay, so it basically counts the number of times a particular word is repeating in a document, so in a particular text paragraph or something. Okay, so that repetition tells the model that it is a very important word, and it assigns a particular numerical value to that word. So that is the purpose of this TF. And IDF, it stands for inverse frequency. So sometimes a word which is repeated several times doesn't have meaning in it. Let's say that we are building a system that predicts whether a review is a positive review or a negative review for a movie. Let's say that we are doing this for the Avengers movie. So there are a lot of reviews in the internet, and we are analyzing all these reviews. So when we perform the same things here, so all the reviews contains the movie name Avengers, right? So in that case, the repeated word which is Avenger does not add any value to it, because all the reviews is definitely going to contain the movie name. So this inverse frequency function finds those values which are repeating so many times, and it detects that those words are not significant, and it reduces its importance value. But this term frequency finds the number of repeating significant words, and it will give a particular value to it. So by this they create feature vectors. So feature vectors are nothing but numbers. Okay, so I'll run this. So what I'm doing is I'm fitting this vectorizer function with this x value. So x is nothing but this content column. Okay, so all these words will be convert to their respective feature vectors. So we don't need to do this in the case of y, because y is already a number, so already it's a label, right? So we are fitting this with x, and this function transform will convert all these value to their respective features. So I'll run this. Now let's see a sample of x. So before it was text, right? So as you can see here, before it was only text. Now it is converted to their respective feature vectors based on the function of TF-IDF vectorizer. So this is how you can convert a text to a numbers that the system can understand. Now we need to feed this data to our machine learning model. So if we have fed this textual data, our machine learning model cannot understand all these strings. But if we feed this transformed text to our machine learning model, it can understand and do the predictions. Okay, so that's what we are going to do here. So now let's split our x and y to training and test data. Okay, so splitting the data set to training and test data. Okay, so create x train, x test, y train, y test. So in a minute I'll tell you what all these variables are. So for this we have imported the function called as trained test split. So we are going to use this function. Okay, train test split. So in this we need to mention x and y, and test size, let's take 20% of the total data set as test data. So let's mention 0.2 and stratify is equal to y under random state is equal to, let's say, 2. So I'll run this. So basically what we are doing is we are splitting our data into two data types, sorry, two data, which has x train and x test. So x train represents training data and x test represents testing data. Okay, so I want 80% of the data to be training data and 20% of the data to be test data. That's why I have mentioned 0.2. So 0.2 represents 20%. So the test size should be 0.2. So those 20% of the data will be stored in x test. Okay, so the label for this x train data will be stored in y train. Okay, so basically this y train contains the labels for this x train respectively, and the labels for this testing data is stored in this y test. So that's why we are creating these 4 columns. So we are using the function train test split. So you need to mention this x and y. So x is nothing but this processed content column, and y is nothing but the label. So you need to mention those. Okay, and then you need to mention the test size, and stratify is equal to y. So the variable y basically contains 0 and 1, right? So 1 represents fake news and 0 represents real news. So if you don't mention this stratify, so that the real news and the fake news won't be segregated in a equal proportion. So when you use this stratify is equal to y, there will be a similar proportion as it was in the original data set. Okay, so and it will be splitted based on it. Now random state is equal to 2. So what is the purpose of this random state is, so while you are preparing this code, if you mention 2 here, the code will be made in a, sorry, the data will be splitted in the same way as it is splitting for me. So if I'm using 3 in this case, and if you use 1 or 2 in this case, it will split the data in a different manner for you. So if you use the same integer value that I'm giving here, we both will get the splitter data in the same manner. Okay, so that's the, it is basically to reproduce a particular code. Okay, so it can be any integer value. Okay, so we have successfully splitted our data into training data and testing data. The training data is stored in x train, and the test data is stored in x test, and the label for x train is stored in y train, and the label for y test is stored in x test. Okay, sorry, y test. So now let's train our logistic regression model. Training the model. So we are using a logistic regression model. Okay, so we have already imported the logistic regression model function, which is logistic regression. Okay, so I'll run this. So as I have told earlier, let me give you an explanation about this logistic regression model. Okay, so so this is how a logistic regression model looks, and as you can see here, there is a S curve. So S represents sigmoid. Okay, so this is the formula behind a logistic regression model. So a sigmoid function basically looks like this. So y is equal to 1 by 1 plus e power minus z. So when you plot the x and y values in this function, you will get a sigmoid curve. Okay, so there is a threshold value. Okay, so if the value is, so in this case the threshold value is 0.5, right? So if your prediction is greater than 0.8, so it will give the label as 1. So if the threshold value is less than 0.5, it will give the value as 0. So in this case, if the threshold value is greater than 0.5, the label is 1, which means the news is fake news. So if the threshold value is less than 0.5, it will be 0, which means it's real news. So for this, we need to make a function in this sigmoid equation, okay, which is 1 by 1 plus e power minus z. Now here we have x and y. Then what is this z? So as you can see here, z is equal to wx plus b. So this is a straight line equation, which is similar to y is equal to mx plus c. Let's understand what are all these terms are. So x is nothing but the input features. So in this case, the input feature is nothing but we have converted those content text into numbers, right? So that represents the input features here, and y represents our prediction probability. So this value will be between 0 to 1, and this will determine whether the label will be 0 or 1, and w represents weights and b represents biases. So weight represents how important a particular feature is. Say for example, we have several columns, right? So in our dataset as title, author, text, etc. So if a particular column has I weight value, it means that particular column is very important. Let's say for this case, the author column is very important. So that author column will have a very huge weight value. So as you can see here, that weight value will be multiplied with the input feature. So if let's say that the text column has very less importance, then that particular column will have very less weight value. Okay, it means the text column cannot signify or cannot influence our result. Okay, and b represents bias, which basically an intercept. So this is the math behind the logistic regression. So this is what happens under the hood of logistic regression model. Okay, now let's carry out our training procedures. So in the later video in our machine learning course, I will make videos completely explaining all the details and math behind every model, such as logistic regression models, XGBoost regressor, KNN, etc. So in that videos, I'll explain you detailing about all these models. So the scope of this particular video is to understand how we can implement these models and make predictions. So I cannot go detailing beyond that point. Okay. Now let's continue with our prediction. So we have loaded this logistic regression model in the variable called as model. Now we need to train our model. So model.fit. So this fit function will train our model. So in this you need to mention xtrain. So we need to train with the help of training data, right? So you need to mention xtrain and ytrain here. So this will take this xtrain value on their respective labels, and it will plot the sigmoid function curve using this logistic regression. Okay, let's run this. So this will train our model. So if you use a very complicated neural network, or if you use a very large data set which contains lags and even more than that, very large data set, the processing and the training will take a large time. So here we are using a simple logistic regression model, so it doesn't take much time. So we have trained our model using this fit function. So we have trained using this xtrain and ytrain value. Okay, now let's do some evaluation on our model. So as it is trained, now let's find its accuracy score and other steps. So evaluation. So in this we are going to use the metric called as accuracy score. Okay, so we have already imported the function called as accuracy score. So as you can see here, so what happens here is the model will be asked to predict values, and that the model's prediction will be compared to the original label values. Okay, let's see how we can do that. Now let's do the prediction first on training data. Accuracy score on the training data. Let's say that xtrain prediction. So it is similar to what we have done in the previous video. So extrain prediction is equal to model.predict. So this model is a trained logistic regression model. As you can see here, we have loaded this to this model variable, right? So this is a trained model. So model.predict extrain, and let's say training data accuracy is equal to accuracy score extrain prediction comma white train. So I know that this project can be a bit complicated. So if you run into some kind of problem while you're practicing it, or if you don't understand what's happening, you can mention it in the comments, or you can reach out to me in either Facebook or LinkedIn or Instagram. I have given all those links in the description for my accounts, so you can reach out to me there. So just mention what is the problem you are facing with the code. I'll definitely help you with it. Okay, so if you cannot understand some point that I am explaining you in this video, okay, so don't hesitate to reach me out. I'll definitely help you. Okay, so if you have any problems with the code, so let's see what we are doing here. So I want our model to make prediction on this extrained data, and all those models, the labels that predicted by this model will be stored in this extrained prediction variable. Now I need to find the accuracy score. So this extrained prediction is the value predicted by our model, and this white rain is the original label. So as you can see here, we have created those respective labels for extrained and stored it in white rain. Okay, so the original labels are stored in white rain. So these both of these will be compared and the accuracy score will be given. So let's run this. Okay, now we can print the accuracy score as accuracy score of the training data. Okay, so I'll print this training data accuracy. This will print the accuracy score. So as you can see here, it's 0.98, which means 98 percentage. Almost it's 99 percentage, which is really good. So in this case, we have used a very large data set, which contains almost 20,000 data points or 20,000 news articles. Hence, we get a very good accuracy score. And as I have told you earlier, for binary classification problems, logistic regression is the best model. So that's why we get a very good accuracy. So you can do it with the other models, other regression models like lasso regression or linear regression as well, and see what is the accuracy score you are getting. But I prefer to use logistic regression when it comes to binary classification. So it is like a general rule. Okay, so we have got the accuracy score as almost 98 for training data, but there is a catch here. The accuracy score on training data is not that much important, but on the test data is important, because our model is trained on training data, and but our model hasn't seen what is the test data, right? So the accuracy score on test data will tell us how good our model is performing. So let me give you a similar example I have given you in the previous videos. Let's say a person is studying for an exam. Let's say that he is studying for some science exam and is practicing some questions for it, and in the exams new questions are asked similar to what he has studied. Okay, so all those questions which he has prepared from a book is nothing but the training data, and in the exams he will be asked new questions. So we know how well the person has performed by understanding his marks in the exam, right? By testing him with the questions that he has not seen in the book. So that is called as test data. So we are training our model with the training data, and we are predicting using that model on test data. So that is what we are going to do here, and that is why we have split the data into training data and test data. Okay, now let's find the accuracy on test data. So I'll copy this. So I just need to change small things. So we need to predict for test data, right? So let's say that x test prediction model.predict x test. So I'm just changing the names here. Test data accuracy, accuracy score. So this will find the labels for X test and it will find the accuracy score. Okay, now let's run this. Now let's print the accuracy score for test data. Okay, so it's very similar to it except we need to change the name of those variables and text. So test, so test data accuracy. As you can see here, it's almost 98, which is very much equal to the accuracy score of our training data. So that means our model has not overtrained with the training data and it is performing very well. Okay, so we have successfully trained our model and we have also evaluated our model and we see that we are getting a very good accuracy score. And now we are in our final step, which is now we are going to build a predictive system. Okay, so making a predictive system. So I have found the accuracy score, everything is done. Now what I want to do is I just want to make a small code snippet where if I give a new news data to my model, it should predict whether the news is real or fake, right? So let's do that. Let's say that x new is equal to, say x new is nothing but the new news for which we are going to make the prediction. Okay, so x new is equal to, let's choose one value from our X test. Okay, so our model hasn't seen the X test data, so I'll take a particular value. So X test, let's mention let's say 0. So 0 means the first row in our X test column, so the first news. Okay, so now we need to make the prediction. I'll create a variable called as prediction. So model dot predict X new. So what happens here is we are taking the first row of our xtest data set and we are storing it in xnew and we are predicting the label of this xnew with this trained model. Okay, so it should predict whether the value is either 0 or 1, right? So I want to print this prediction, so this will give the label as either 0 or 1. So print prediction, and if prediction is equal to 0, so 0 means real news, I have mentioned earlier, right? So 0 means real news. So if the value is 0, we need to print that the news is real. Else, so else means, so if the value is 1, we need to print that the news is fake. So the news is fake. Okay, so let's run this. So as you can see here, it has returned a label called as label as 1 and we have seen that the news is fake. Now let's check whether this prediction is correct or not. So what you can do is you need to print the label of this respective column, which is 0th column. So let's say that print x test 0. Okay, so I'll run this. Sorry. So it need to be y test. So y test contains the label. So as you can see here, the label is 1. So our model has predicted correctly that the prediction is 1, which means the news is fake. And in the original label of the y test, as you can see here, so this is the label for x test. We have found that the value is also 1, which means that the prediction is correct, right? Now let's check for 1. So here the label is 1, which means the news is real. Let's see whether it is correct or not. So I'll just put 1. So as you can see here, we are getting the label correctly. So you can just try it for different values and see whether the model is predicting correctly. So the news is real. So 3. So it should print 0. So as you can see here, our model is predicting correctly. So this is how you can make a predictive system. So when you give a new value, our model can predict its label and tell whether it's real or fake. Okay, so that is about building a fake news prediction system. So let me give you a very quick recap. So we have seen the various features in our data set. So it basically contains 5 columns. So in the label, 1 represents fake news and 0 represents real news. So we have imported all the libraries such as NumPy, Pandas, Natural Language Toolkit, etc. So we have found the stop words, which are nothing but those words which doesn't add much value to it. So and then we have imported our data set to a pandas data frame, and we have found the shape and the sample of our data set. So and then we have found the number of missing values, and then we have replaced it with a null string or a empty string, and then we have merged the 2 columns, which are the author column and the title column, and this is what we are going to use for making the predictions. Okay, so and we have stored it in the column named as content. So once we have done that, we have separated the x and y, as x is all the data and y is represents the label, which is either 0 or 1, and 0 represents real news and 1 represents fake news, right? And then the important step, which is stemming. So stemming basically reduces a word to its root words. So we have did that here, and then we have removed all the stop words, and on the main significant words we have used this spot stem, which is spot a stemmer function. And once we have done that, we have stored it in this content column again. So after that, the important step is we converted all this text data to meaningful numbers using this function TF-IDF vectorizer. So this will convert all the text to their numbers which the machine can understand. So once we have done that, we have splitted our dataset into training data and a test data, and then we have seen what is meant by a logistic regression model and a small explanation on how it works. And then we have trained our logistic regression model with the X train and Y train, and we have found the accuracy score for training data and the test data, right? So and then finally we have just made a small predictive system that can tell whether the news is a real or fake. Okay, so I hope you have understood all the things I have covered here. So there is a good chance that you may not be clear about some things, so please reach out to me in some social medias like LinkedIn or Instagram. I'll definitely reply to you, and I'll just try to sort that problem out. Okay, so thanks for watching.